All right, so we go like this. There's Graham. Hello, Graham.
Yes,
All right, so I'm going to attempt to share screen because Jim is going to talk to us today first about soil families. So
here's the middle one.
share screen dose. All right, can everyone see that screen?
Yep.
Yep.
Thank you very much. That there. All right. There you go, Jim.
Away we go. Okay. This is a sort of a reshuffle of a talk I gave at the CSSS meetings in 2021. But essentially, it's a proposal to changes to the soil family taxa in the Canadian system. Oops. Okay. So, okay, as most of you probably know, soil family occupies fourth level in the hierarchical taxa of the Canadian system. It was originally developed in the 1960s to bridge the gap between subgroups of the third level and soil series, which is the fifth level in our primary mapping unit. It was introduced because the number of soil series was far too large compared to the number of subgroups. And the original purpose of it was to provide a framework for checking and establishing limits for soil series, define and retain groups of soil series within the same subgroup, and then intended to provide a means of grouping soil series to apply similar soil management and to some extent, this is their words, not mine, engineering practices. So challenges, as most of you know, and anybody that's practicing, the soil family category is pretty much ignored in our system. The potential use of it, and the big use of it here would be to use the category as a tool to group soil series consistently for the purposes of applying management practices, original intent being both agronomic and engineering. The soil family names are attribute based. There's 8 attributes, and it's very cumbersome to use. That's just an example there of one of them. There's several inconsistencies, and the biggest inconsistency is with the particle size criteria, which we'll get into in detail here in a minute. And some series were established long before the family category came along, and therefore some series are actually divided into several families. So some readjustment there is going to be required. Okay, so we're going to talk about primarily mineral soils here. The organic soils, actually, believe it or not, are not too bad. But okay, first of all, okay, the various attributes for the soil family are particle size, mineralogy class, reaction class, which is pH of the sea horizon, calcareousness class, which is of the sea horizon, depth to bedrock, depth to permafrost, which is usually omitted. That's sort of the 8th one, which they talked about. If you noticed from the previous slide, we only had 7 attributes: the soil temperature regime and the soil moisture regime. It actually says, believe it or not, in the CSSS 3rd edition, that you, for convenience and brevity, a common soil name should be assigned to each of the soil families. So the example I've got there is for an Orthic Graylufosol, which is the subgroup name, of course. Fine loamy mixed neutral cold subhumid family could be the Orthic Graylufosol Breton family, the Breton series, of course, being the most common series in that group. So ones we're going to talk about changing here, the big one is the soil particle size class, and soil particle size should not be confused with soil texture. Soil texture refers specifically to the fine earth fraction, or the less than 2 millimeter size fraction. Particle size class combines both texture plus the coarse fragment content, or the greater than 2 millimeter size fraction. So it applies to whole profiles as a weighted average of a segment of the control section based on the current verbiage in the current Canadian system. That's different, again, from soil texture, and that soil texture applies to individual soil horizons. So it's a weighted average of the control section, essentially, in terms of the particle size. Other things we're going to be looking at changing, these are just minor changes, though, to the mineralogical class, calcareous class, and the depth of bedrock, or as terms of elliptic or elliptic contact, based on consistency with the proposed leptosolic order. So originally in 1978, when this thing was proposed, this is the current soil particle size triangle for families. And it was regarded as a compromise at the time. So it was a compromise between engineering and pedological classifications, which in my estimation, that's where the problem came from. It was a compromise. And in so doing so, they essentially wanted to compromise between engineering and pedological classifications, but essentially in doing so, it made it non-functional, because there was a difference then in the limit of the sand and silt was at 74 microns as opposed to 50 or 20 microns in pedological classifications. Oops, wrong one. Thank you. Okay, so it was originally based on the USDA system. Again, it's a balance between engineering and agronomic influences. The horizontal breaks in the triangle there are at 18, 35, and 60 clay content, reflects differences in plastic and liquid limits or engineering properties. It's important agricultural differences were on the other scale, or the sand scale there, where there were differences between coarse and fine silty and low classes based on capillary rise and available moisture holding capacity. So basically, the soil family was intended to allow groupings of similar soils with similar response to management and to some extent engineering. The interesting part is it's more geared towards engineering than it actually is towards pedological differences. So the issues then, there's a number of them, okay, is currently the family particle size class boundaries don't match up with soil textural boundaries from pedological definitions. So it's very difficult, particularly with legacy data prior to 1960, to actually correlate that data in terms of a family classification. And the classification effectively requires additional analysis, particularly with particle size analysis. So the current particle size does not include skeletal categories for soils with silty fine earth fractions. In other words, a skeletal silty class doesn't exist, but those are possible. They're rare, but they are possible. So what we're proposing then for a change, or a change to the particle size triangle, is something that you're seeing on the left-hand side of the triangle, which is, or sorry, of the slide there, which is based on the S-type forest ecosystem classification system, so that the boundaries then align with the current soil textural triangle, or fine earth triangle. So you'll see the boundaries there are somewhat shift, but the names that are used previously, or with the previous or the current soil particle size class, are consistent and similar to the ones that we're proposing for use. So from I'm a sort of a list here. So we would be keeping the definitions, then would be there. There's fragmental, which is greater than 90% coarse fragments. Sandy skeletal, which is essentially between 35 and 90% coarse fragments. We're adding a silty skeletal category, loamy skeletal, clay skeletal, obviously. And then from the point of view of, instead of a coarse and a fine silty coarse and fine silty classes, there would just be a silty class, which is includes both the silt and the silt loam textural classes. Okay, from minor change to the mineralogical classes, essentially these are the ones that are currently there. The one in the yellow is essentially just adding, and it's more or less for inclusiveness. In fact, most soils actually fit into that mixed mineralogical class. Reaction class would stay the same. calcareousness class, we would add a new one, a non-calcareous. Right now, anything with acid or neutral pH is just inferred that it's non-calcareous for obvious reasons. So that to formalize it, we're going to add that class. The leptosolic or litholic is currently the lithological class, would be the leptological class, and it would have to be changed for consistency with our proposed leptosolic order. The cryosolic or permafrost class would stay the same as it is, and the soil temperature class and the soil moisture regime classes would stay the same as well. Okay, so recommended revision for conclusion, the recommended revision to the soil particle size triangle to align with soil textural classes. Promotion of the use of the common series names for family names in place of the long, cumbersome attribute-based family names. And improved functionality with soil classification should aid in extending the application to agronomic recommendations among soil series. So that's pretty much presentation. So any questions, we'll try and answer.
All right. Any questions about proposed modifications to the soil family? Paul, please.
Yeah, I've got kind of a minor one, Jim. I'm looking at your paper, and in table 7, you present a reworking of the soil family depth classes for mineral soils. And I actually didn't know until I read this paper that we had depth classes for permafrost. And I'm kind of curious to know whether anybody ever used them. I mean, and I'm not sure how you would use them. I mean, if you went out in the field now and went out in the field in 2 months or 3 months from now, you get completely different observations depending on the thickening of the active layer as the summer progresses. So I don't know whether this has ever been used and whether there's a lot of value in tweaking it.
Yeah, not to my knowledge either, Paul.
Yeah, I did put in a query to Scott Smith just to see if he knew anything about this, but I haven't heard back from him. Okay, that's all. Thank you.
No worries.
If I can respond a bit. Sorry, I see Tony has his hand up.
Oh, hi. I was interested why you kept with the terminology, I guess, of fine loamy, coarse loamy. I certainly agree with the aspect of tying it to our textural triangle, and the particle size classes, or the textural classes, I should say. Why not go back to the 74 version with coarse, medium, and fine? Those are lumpings of the textual classes, and they correspond with the textual triangle. And that is sort of what we use in Alberta, because a lot of our soils are loam surface and they go to a clay loam, they're medium textured. If they have another, go to sandy loam, they're coarse textured. And we make a distinction with that. I just was wondering how you thought of those.
Again, like originally, back when we originally proposed this, was looking at this like 2 or 3 years ago, I was trying to stay consistent with what would have been used in the past and classification names that would be used in the past. I have to agree with you. Yes, really in Ontario as well, we only use like three textual classes usually from an agronomic standpoint. So your point's taken. I think that might not be a bad idea. To instead of using, I think it's 5 or whatever, is to actually go back to the original. I think it's 74. Did you say? I think that's right.
Yeah.
Yeah. Go back to that. I really don't. We were trying to be consistent, with what had been used already, but as I said, not many people are using it anyway, so yes, it might not be a bad idea to just go to 3.
And the other one is I was just wondering if we do change the criteria for fine loamy to fine clay, if you want from 35% clay to 40%, does that impede on the engineering criteria for those engineers who use those current breaks?
Well, when
If we change it,
Oh, I've consulted with a number of my engineering colleagues, and point being, they don't even look at it. Okay, they'll go out there. First of all, they're not even looking at what we call soil that's being scraped off, and they're more interested in what we refer to as subsoil, and they're going to do their own engineering testing of that material anyway. So from a family standpoint, especially, they wouldn't even look at it. So I think I think it was a noble shot to try and include it, but I don't think it's really the compromise really worked, I guess is what the words I'm looking for.
okay.
So from our perspective, at least, I think we should stick with the agronomic definitions and stick with those. It just makes more sense instead of sort of expanding it out into the engineering world. They kind of do their own thing.
Okay, yeah. So we have free license if you want to go back to changing the terminology then.
I would say so, yes.
Yeah.
We wanted to, yes.
The other final point was in terms of the skeletal or skeletal or however you want to pronounce that word, we always had problems. A lot of our soils, or we often make breaks at 20% coarse fragments for gravelly. So it's 20 to 50% is gravelly, greater than 50 is very gravelly. 35% is a really, another break that we're imposing on.
Hang on now. Okay, subtle difference, Tony, and it might be the difference you're looking at. 35% in our definitions is 35% by volume,
But
which if you do the calculations works out to 50% roughly by mass. So those 35 and 65% that you see for the breaks actually refer to essentially 50% by mass and 75% by mass. So it's a difference in the way it's measured.
okay, but yeah. Are we going to still use that term though? Because a lot of people can't relate to those. I mean, most people will say it's gravelly, very gravelly, or fragmental, or cobbly, or stony.
Yeah, well,
We're just
all those
lumping
terms,
everything together as skeletal. I just sort of think
it's sort of, there's the cobbly, yes, that refers to the type of coarse fragment. Then there's the amount of coarse fragment material that's in there. And the reason we go with volume is that it's just far easier to estimate by volume in the field than it is to actually measure gravimetrically. You can't basically, when you get into the gravels and the coarse fragments, you can't bring home a big enough sample to accurately measure it by mass. So therefore, that's what we're doing it by volume.
No, I agree. I'm leave those in the field.
Yeah.
Okay, well, thank you.
Yeah, but Tony, I think like isn't like so those qualifiers like gravelly, very gravelly, like those tend to be applied to as modifiers to the individual texture classes, where the concept of skeletal and fragmental is at the family level, right? So they're applied at for different purposes, right?
Yeah, different purposes.
Right, but you sorry, I'm taking a lot of time here.
Oh, no, this is what we're here for.
Yeah.
But we're trying to, we lump those to be people in the field are using those terms, and then we're suddenly imposing new criteria in those family classes. Where if you were to look up a particular soil name in the soil names file in Kansas, and you suddenly are going, oh, it's been described as gravelly in the field, but now we're sort of saying, oh, it's not even skeletal. It's just fine loamy.
Yeah, so the break there is between.
And this is where it gets
15
confusion.
15 to 35 gets that gravelly term added on to the textual class. But that's
Yeah.
that's within a horizon.
Right. But when you're going to the mineralogy and you're describing reaction, you're wanting to add those finer breaks for pH classes. I think you better watch what we're doing. If we're going to make sure that we're staying within the family class, let's leave them at the broader level and not get too hung up on the pHs at a more detailed level. What I'm getting at is you're using the, gosh, I lost it. The reaction, and you've had the big classes for acidic, neutral, and well, I've lost the other term too, sorry. But
It's fine, yeah.
then you break it into finer classes, and I'm wondering why you're doing that in this family paper. That's all.
Oh, I think that was just, Tony, that was just to show how the individual texture or the individual smaller pH classes fit into the bigger ones. I don't, at the family level, I don't think we would propose using the more, the larger number of classes. It was just, I think it was to illustrate how everything lumps up into the higher categories.
Yes, yeah, we're only proposing.
Okay, you got, so you would still stay with acid, neutral, and alkaline.
Yeah, right.
Correct, yes.
So, okay.
Yeah.
I got confused in the paper. I thought you were going to the next break.
No, no.
Well, yeah, no, because I think then, I mean, could you imagine the proliferation of soil families at that point, right? Yeah, no.
That's right. No, I was just wanting to clarify. Okay.
Yep.
Thank you.
Thanks, Tony.
Yep.
Graham. Okay. Constantine.
Yeah, I would second Tony's comment on using classes that already are used in Liberta, but it is actually used across Kansas system as very coarse, moderately coarse, medium, moderately fine, fine, very fine. So those classes are criteria for soil series at this point.
Well,
So,
no, those are defined as parent material texture classes.
Yep.
So
And
I would be interested if somebody did a deep dive into where all of these things came from and who made them up. The parent material texture classes, the individual texture classes, the soil family texture classes. I mean, maybe we can create a couple of additional ones to confuse us. Yeah.
But those are consistently used as criteria for soil series across Kansas. And why would not just, and it's assumed it is because series are subgroup on particular parent material, right? That's the kind of concept of it. So then why would not just transfer that those categories into the families as a criteria? Just
so if we did that, Constantine, you'd almost be suggesting that we just drop the soil family particle sizes.
Or we copy them.
What's the
and
point?
We can say moderately fine. We can use moderately fine Chernozymes as a, or like as a family. Anyhow, that's one. Second one was comment to what Paul says about craic families. The only time I use them, and that is a marginal case, when organic soils have permafrost below 1 meter, and they are not cryosols per se, but it is quite important construction management aspect. So it's shallow craic family. That's the only time. But I'm always confused with the definition of Z like modifier when it doesn't say seasonally frozen, it says frozen. So in Alberta, I supposedly describe APZ and BMZ when I just do soil survey in February, and we do soil survey in February once in a while. So that maybe Z needs to be specified to permafrost, but as for families, the only case is deep permafrost in organic soils. And the third one I had, the climate. so we just don't change the climate, like wetness and temperature families. Did you have any thoughts of global warming or global climate change?
Well,
No,
I think,
I'm actually serious with permafrost, permafrost receding. It
Yeah.
may be a big change, but maybe even at family levels at this point. That's all I have. Thanks.
It's, as you know, it's a bit of a can of worms. That diagram that I showed quickly on the one slide there, that's, oh boy, probably early 70s. So
but the,
it should be probably updated considerably
well,
since
but I was
then.
gonna say, the question is, do the classes change or does the map change? I think the map changes, the classes probably don't need to change, but
Yeah,
someone should
agree,
certainly
yeah.
redo a map of soil moisture and soil temperature regimes across Canada, because it hasn't been done in many, many, many years.
I understand it is outside the topic of the family classes. Classes
Yeah.
probably should stay the same.
Thanks, Constantine. Richard?
You're muted, Richard.
Yeah, I'm struggling on my end, sorry. I'm just reflecting a little bit, Jim, you referred to agronomic, and I'm assuming that you mean a little bit broader in terms of environmental response as well, and not just agronomic response. And in that regard, would you be able to throw up that slide again where you were talking about the calcareous or reaction classes, something like that?
Maybe.
I'll get my technical.
Maybe.
Keep talking and I'll see what I can do.
Now you put me on the spot.
Hang on, I'm almost there, I think. These ones, right?
It was right near the end, I think, before you came in with the conclusion slide.
Yeah, just give me 1 sec to share now. That one?
So that one?
That's the one, yeah. So when we're looking at contemplating this issue of the reaction class, we're typically thinking about the broader reaction of the matrix, aren't we? Is that a fair thing to say? I'm throwing that out at the group.
pH of the parent material was sea horizon.
Sea horizon, parent material.
Okay. Where I'm going is the conversations that I've had over the years with my colleague in the Ministry of Natural Resources here, and he's an ecologist, and so they're looking at the ecological response on different landscapes and so forth, and so even though when you would take some soil and you do the standard tests, pH tests or whatever, or drop some acid in the field on the soil, you might find that you've got a relatively non-reactive soil, so to speak. But in southwestern Ontario especially, we've got a lot of the coarser materials are calcareous in origin. And so even though the surrounding soil mass might be quite depleted of carbonates, and so there would be no general reaction if you put this acid on the matrix of the soil, or when you do your in-lab test where you've sieved out the greater than 2 millimeter fraction and done, you might not find much reaction or calcareous, but because you've got this background fragments, larger fragments, gravels, cobbles, whatever, that are calcareous, that can have a profound difference on the ecological response of that landscape. There's enough calcium, magnesium being released from those larger fragments that it's able to sustain a very different ecosystem than if those coarser fragments were granitic, for example. And so the suggestion that my colleague has come up with is that somehow beyond this normal calcareous classes that we've come up with, which again, we're generally thinking about the matrix, really. We're not thinking about the coarser components, that we bring in some kind of capacity to reflect that, yes, even though the soil is essentially devoid of finer carbonates, we've got these coarse fragments which are calcareous. And so he came up with these terms of skeletal calcareous, fragnal calcareous. So I'm throwing that out for reflection. Does it have any value? We talk about agronomic, fine, but if we're also grouping in our soil classification system is supposed to be more environmental in general rather than just strictly agronomic.
Right,
In our
but
calcareous,
Quick question. Does it specify in the family classes if that calcareousness is measured for fine earth or for the whole soil? And the same with mineralogy, same few other parameters. Does it specify it or it is assumed?
I think it's assumed, is it not, Constantine, that the pH reaction class type stuff is on the fine earth, what you have sieved out.
Yeah, agreed.
Yeah, I agree.
Yeah, just for my knowledge, like, yeah, I'm not missing anything, just in case.
No, it's I think Richard's got a point, but I think traditionally and the way it's currently done is, yeah, it's based on the fine earth fraction. But yes, okay, in terms of ecological and supportive plant nutrition, that is a consideration, but I'm not sure for our purposes, we have enough information on that as background in order to say, yeah, we should start classifying that way or this way.
But I think, Jim, when you're looking at a soil in vertical section and you take a pH estimate in your major root zone, you're going to be using a fine earth fraction. And if you have calcareous larger fragments weathering in there, it will probably have a fairly high base status, and it will also have more of a eutric pH range to it as well.
Yeah, typically,
yeah.
I think it's more of a rare case that you actually get a granite mixed in, for example, coarse fragments mixed in with calcareous fine earth fraction.
And then depends on whether you're in Southern Ontario, Central Ontario, Northern Ontario, or on the prairies. You find both on the prairies in some cases, definitely.
Yeah,
We have a lot.
But
We have a lot of.
Canada's a funny place.
So I would imagine that if in the certain scenario that you're talking about, Graham, where you've got some, again, fragments of larger fragments of calcareous rock, dolostone or something like that in the system, yeah, probably the cation exchange complex is going to be dominated by calcium and magnesium. So you're going to have pHs in around 6.5. It's not going to be this, because you've essentially leached out what would we consider the free carbonates, that stuff that might have been originally in the silt fraction or the fine sand fraction. You've leached that out. You won't be having pHs up in 7.5, 8 neighborhood anymore.
That's right. Yep, definitely agree with that.
But and yeah, you might say, Jim, that, well, we don't have much data on what that means, but clearly within the ecological community, they do recognize that. And would it be such a complication just to add it in as a potential option in that table that you've indicated with extremely calcareous, moderately calcareous?
Okay.
That
And having worked the last 20 odd years or 30 years with the ecology folk, they tend to see soil or describe soil also as just the solid stuff underneath the plant that it grows in.
substrate.
Substrate, yes.
And we'd have, I think, on that topic, I think we'd have to look a little bit more closely, table 2A, 2B, and 2C in the book, right? There's key to mineralogy classes applied to families of any particle size class, and then there's some qualifiers for applied to soil families having fragmental, sandy, skeletal. Yeah, determinate, and so it gives you the determinate particle size fraction that you're supposed to use to assign these modifiers. And so, like for example, for the first one, there's these modifiers of, then these are things that people don't use because we don't use the soil family because we haven't made it useful for ourselves. But like carbonatic, serpentinitic,
Yeah.
gypsic, sulfurous, or sulfurous, and then there's mineralogy classes for the 0.02 to 2 millimeters, so micaceous, siliceous, mixed. And then there's some specifically that apply to the clay-sized particles. So like to define the types of clays that are present. Obviously, that's not something you're going to do in the field, most likely, unless you've got really sharp eyes. But so I think that there might be some opportunity to kind of review in there how those classes are assigned. I don't think it's something that we really looked at in the paper. We were more concerned with just the particle size classes themselves and not necessarily some of these additional descriptors that go along with it. So I think that might be there an opportunity to review some of these things.
If I can kind of throw a red herring in here as well.
Yeah.
One of the targets I would assume from this reevaluation and improvement of the classification system is to train the next generation who, with luck, will also, as well as a classification training course, will be provided some training using that fine new book the Society has put together, where Jim led a chapter on mineralogy, so there'll be a better understanding of mineralogical classes, because people, hopefully even in biology, will get a background in this material, and engineering perhaps. As I said, a red herring, but it is looking at your target audience going forward, not necessarily looking at the audience on this discussion.
Rongui?
Yeah, I like for the carriers, the classes, Jim, I like the idea to put the non-carriers over there. And, in Manitoba, because we are considering the agronomic impact of the carrier over there. For example, phosphorus fertilizers efficiency is also depends on the soil pH and the calcareous reaction in the soil. So we divided the strong calcareous from the 6 to 30 to another two categories. For example, moderated calcareous, we divided that from 6 to 15, and strongly 16 to 25, and very strongly 26 or 25 to 30. So that will fine tune our classification of calcareous classes.
Right. So you're
So-
so you're saying at the family level, you've added, you've refined the ranges and added classes essentially in between, or to further refine the broad classes that are currently in the Canadian system.
Yeah, that's what I'm thinking. And in the field, it's very easy if we only have 2 or 3 classes, because it's from the non-calcareous or weekly 1 to 5 or 5 to 40%. It's very easy. However, from the agronomics point of view, we need a little bit better to refine them to divide it into more categories. Yeah, thank you.
Thank you. Richard?
Jim, if we go back to the table, the triangle that you've suggested for the new family texture classes or particle size classes.
Richard, you're killing me.
Sorry. I mean,
That's
that's
okay.
ultimately, I think, the major change. I'm so in
It is,
first
I'm gonna pull it up.
first respect, I think simplifying the relationship between the textual classes and the family particle classes, I think that is attractive, right? Those lines that they sort of follow along the groupings. They follow along. They don't sort of. They'd actually follow along the groupings for the textual classes. My probably underlining question though is you started off your discussion on this issue that the engineers and the pedologists were coming together and trying to come up with some kind of divisions that meant something to both of them, and we're really not sure what that was. But I'll ask the question: what? Yeah, if we go back to the other one, then what, according to the groupings that are being proposed here, what distinguishes what's you calling silty family particle class from coarse loamy from sandy? Why do we group those? What's the purpose for grouping the silt and the silt loam together? The loam, the sandy loam, the loamy sand, the sands. What makes those groupings unique and distinct from the textural classes that you've thrown into the other family particle classes?
Well, I think those, as I said, this triangle that I put up there that proposed is based on the forest ecosystem classification, which at the time, to me at least, made more sense than the current particle size triangle. So the basis for that, I didn't delve into or didn't dig into, but again, wanted to sort of use something that was kind of out there already and would have had some basis, I'm assuming. But that would be essentially it would be based on that original triangle. So whatever the logic would be for that triangle, that forest ecosystem triangle, would be the same basis for the divisions that we would be using, or based on the proposed ones. Now, that having all been said, going back to Tony's comment, if we break it up into, instead of 5 particle size classes or base classes, if you will, we only end up with 3. That I'm actually in favor of that. And reason for it is that it's fairly well established, those three classes. As well, it reduces, okay, think about it, if the more classes we add at the family level, the more you have to split out technically 2 different series. So you're proliferating the number of series at the series level if you split out the families. So that's why I'm thinking I've also done some thinking on, as Tony suggests, that it was it's very common to use those 3 classes. So in recent months, I've been thinking about maybe that was an oversight on our part to put so many classes in, and it would just be simpler if we could back it down to 3.
Yeah, because ultimately I'm thinking of so suddenly I'm standing in front of a keen class that when we throw up this new family particle size triangle, and to get this question, so why have these been grouped here? What's the underlying reason? Yeah, if it's forest according to the forest ecosystem, clearly it must be some kind of ecosystem response that they're justifying that on. Is there any mechanical justification there in terms where from the agronomic perspective, we also have to think about the mechanical behavior of the soil, its hydraulic behavior. There's a variety of things that come into play, aspects of the soil that come into play when we're talking about texture. And so when we're going up to that higher level, what is it really? How does this group really distinguish itself from the other group? And I'm sort of thinking, what am I going to say to the students in response to that kind of a question?
Yeah, well, I think first of all that the inclusion of the engineering properties in there caused a lot of problems or original issues with the with the using the family particle size triangle. I admit that that's an important thing to consider, but at the same token, I don't think it really has any place in our, not any place, but it's got, there's more emphasis on that than there should have been originally. So
I
guess
agree
what-
on that point. I agree on that
guess
point.
what I'm saying we should be backing away from using those definitions and letting the engineers kind of, shall we say, do their own thing. But in terms of the breaks, essentially now you're talking about a grouping of soil textural classes into sort of a major particle size class versus any break due to either available moisture content considerations or plasticity considerations. If you're talking about the engineering properties.
I should say, Richard, you know, from the drainage paper that we did that, you know, there's certain properties of these soils, the way that we're grouping them, that I don't think are, I would say, are not appropriate. So for example, at the parent material, Kansas classes of moderately fine, you would lump silty clay loam, and sandy clay loam together. But if you look at soil hydraulic properties of sandy clay loams versus clay loams and silty clay loams, they behave very, very differently. And so is it appropriate even to have those grouped the way that we have them, just based on some basic fundamental soil chemical soil physical properties that we could be looking at? I think there's a lot of questions that we can ask of how we came up with these breaks, and not only for the particle size triangle, but even for the parent material texture classes that we're looking at as well. And so, I mean, the other thing we have to keep in mind, of course, is that the texture triangle, the way that it is, and the breaks between the texture classes, at least for pedological work, are fairly well established everywhere else in the world as well. And so I don't think that Canadian pedology will have the muscle to flex and change other systems around the world to adopt our new, you know, if we come up with these different breaks or something like that. Certainly, I would be interested to see what the Americans think of us changing the particle size triangle. I know I've had discussions with some soil scientists recently on trying to decide, for example, in the legacy data that we have in Ontario, if you have something that is silt loam, which particle size class does it currently go in? Because it could go in 4 different classes. And so there lies one of the big struggles with a system that really doesn't align with our texture classes, right? Like, I feel like all of these things need to be hierarchical in a way. They need to be nested within one another. And this is one of the things that for me is very problematic in trying to apply the particle sizes and talk about soil families when we have, you know, when a single texture class can fit into 4 different particle size classes. To me, that's just irrational. That's my rant. I don't know. There's 2 hands up. We have 5 minutes left for this topic, and I don't remember who was up first, so I'll just go with the first on my screen, which is Kevin Keys.
Yeah, thanks. Can you go back to that slide you had before this one? Just another quick comment on that one. Sorry, after. Yeah, this one here. When I look at the left-hand triangle, I can't really reconcile the terms with the breakpoints, because it seems to me if you're going to be increasing in sand, you would have to start also increase in clay to make it finer. So the fine loamy shouldn't include sandy clay loam. I would think the coarse loamy should include sandy clay loam, because the more sand you have, the more clay you need to call it loamy. And same idea with the sandy clay. I guess you could throw that in with fine loamy instead of, it just seems that the more sand you have in some of these categories, the less clay you need to call it fine, which doesn't make a lot of sense to me. But anyway, that's one comment. And then the other one I'm just throwing out there is, you mentioned obviously that the family classification hasn't been used much, and you had obviously some good reasons to support why that has been the case. But then I kind of in keeping with some of the earlier discussion, what do we want the family class to be used for more going forward? And so if we kind of think of that as a more of the goal of, you know, updating the family classification for future use, we may want to look at other descriptors that aren't even on the list now, and you know, to make it more of a level of the hierarchy that people are going to want to use because it has more use for them than the current one does now. I know, for instance, some of the pH or the calcareous ones there. I mean, for where I come from, I would always be in the same unit. There wouldn't be any range whatsoever there. So I'd have to be looking at other descriptors to start wanting to group things in a meaningful way for management interpretation, ecological or agronomic, whatever. So I'm just throwing that out there as a consideration.
In terms of the calcareousness class there's currently, I guess there's 3. And if you go through and look at all the various series, that anyone that has a carbonate content greater than 1%, I would say 85 to 90% fall in that strong calcareous class. There's no differentiation whatsoever. So yeah, and there are also other subclasses like the pH, not necessarily applied to the family, but there are, I think it's weakly, moderately, and strongly. I can't remember the exact terms, but there's breakout there. You can break the strongly calcareous class into 3 other ones if you're so inclined, and if that makes a difference to you in terms of your usefulness or application of your soil. But for at least for the family, as I said, most of I'm going to say 85–90% are in that strongly calcareous class.
Thanks, Kevin. Constantine, did you still want to get in on this one?
Oh, very quickly.
Yeah.
So in Kansas and in soil name file in Alberta, we use these categories on the left-hand triangle. We just call them very coarse, moderately coarse, moderately fine, fine, very fine, and they are called textural groups. So
Yeah.
why we're not using the term textural groups? Because it is exactly same meaning.
Yeah, that the two are texture and particle size are you know, fairly well graded together, and that's what I think a lot of it in terms of the terminology causes confusion.
And it could be terminology could be simplified if we go to textural classes and textural groups. That makes it uniform across the system, and it brings it to more use of family categories. That's all I'm saying.
Yeah. So like Constantine, the suggestion I think that would be like, why don't we use those regroupings instead of particle size class at the family level? So we'll use something that is already being used in Kansas and it's already coded out, and that already regroups things based on, I mean, it even says it in our thing, USDA soil texture classes. Obviously we have one additional class, but yeah, I agree with you, Constantine. The regrouping, the parent material textures in Kansas, I assume were created because particle size was way too problematic to use. And so they went with, let's just regroup the texture classes.
Mm-hmm.
Thanks, Constantine.
And it is used by many, many people already. So why we don't just adopt what is already used and put it in family level? Yeah, so we can maybe leave the particle size classes with the engineers and they can use them all they want. Because realistically, I mean, at least in Ontario, and I'm not familiar with too many of the other provinces and what's included in the more modern soil surveys, but by modern, I mean the ones that were done in the 90s, so it's not really that modern, I guess. But you know, in those reports, there was a section always in our reports, at least in Ontario, that were written by engineers, and they were about all the engineering properties of soils. And essentially, the soil survey
staff would give the samples over to the engineering. It usually was written by University of Waterloo Engineering Department, and they would do all the testing, and they would put together a section that specifically addresses the engineering characteristics of the various soils. And that was a standalone set of tables and descriptions, and then you went into the agronomic descriptions. And so there was never this, we never dealt with really the particle size stuff at in the soil series descriptions per se, other than sometimes they were adding the soil family names, the long kind of descriptor names to the tables.
And back to the engineers, we use those categories of textural groups in reclamation suitability, in agricultural suitability. So it is used in all sort of engineering, not exactly engineering, but it is in land reclamation. Yeah, that's what is used. So
Yes.
maybe that's what we should keep using.
Sounds good to me. It does certainly simplify things. You know, we have to adopt whatever, when the engineers, for example, we want to use engineering data, we have to adapt it to our system to make it work. And so I don't see why it's unreasonable for us to do this, for the same to occur in the other direction, right? We use the classes that are meaningful for our discipline. And if they choose to use our data, they can do the interpretation to transcribe it into their system. So, okay. 2 minutes over, we are now going to stop sharing this screen, and we are going to I'm going to invite Anne to take over and talk to us about the work that the Anthroposol group are doing.
Okay, thank you, Dan.
So there you go. It should be free for you now.
Yep, I'll just set it up here. Okay, everybody see it? Okay, great.
Yeah, yes.
Okay, so I'm going to give a little bit of an update on what we have been doing. So Constantine, Leonard, and I have been working on this since our January meeting, and we're quite happy with where we've gotten. So we're quite excited to hear what you have to say today. And I just want to take the opportunity to thank everybody on the working group that has been so helpful in discussions and decision making, and particularly a big thank you to Tony, Scott, and Paul, who've been roped into some very interesting critical discussions over the last few weeks. So this is just a little summary of where we've come from. We've done a lot of clarification, additions, some deletions from the paper, the latest paper, the 2022 paper. And those include finally making a decision on positioning of the anthroposolic order in the book, at least for now. We've got a draft chapter completed at this point in time. Of course, we recognize we're on a very dynamic trajectory, and discussions like today and leptosols, et cetera, will help to evolve what we're doing. We have a draft key completed as well, and we've been working on addition to other sections of the CSSC 4, and that's also completed. So when I say completed as of now, recognizing there will be further discussion and potential changes. So the just to start out, just a reminder of the order. We've clarified a few things. So still the definition is pretty much the same for anthroposols: highly modified, transformed, or constructed by human activity. We've been really focusing a lot on the necessity of the visibly evident soil disturbance or modification that is very much a part of recognizing and classifying anthroposols in the field. So, of course, we have these one or more natural horizons that are removed, replaced, added, or significantly modified by human activities. And there's been a lot of discussion around what is this significant modification and how do we separate it from routine agricultural practices, et cetera. So that's now much, I think, clearer in the actual chapter. So I just wanted to remind everybody of the diagnostic criteria. That has not changed. Leonard, did you want to say something?
Oh, I'm okay. Do you hear me?
Yep.
No, you're good.
Okay, I just saw your name light up and I thought you wanted, yeah, please, Constantine and Leonard, anytime you want to add something, please do. So then just a reminder about the diagnostic criteria, anthropogenic origin of parent material, the diagnostic D horizon being greater than or equal to 30 centimeters within that 1 meter control 100 centimeter control section, and making sure that the diagnostic horizons of other diagnostic features of other CSSC soil orders are not present. So that takes us straight into the groups, the great groups. And some of this has been modified a bit. This is what we are ending up with. Technic anthroposols, spolic anthroposols, and carbic anthroposols. And these are based primarily on the presence or absence of artifacts and organic carbon content. So you'll see under Technic, for example, we've been very clear about greater than or equal to 20% by volume of artifacts, and we've clarified that this would be in a layer or horizon at least 20 centimeters thick, and it could be combined within one or more of those soil horizons. And then moving down to organic carbon content, that would be any. When you move over to the spolic, you start having less artifacts and more organic carbon. So we put the numbers in there, and we've also defined that this would be for organic carbon within more or less 50% thickness of the control section, to be a little more clear. And then same with carbic. Now we're looking at greater than 17%, whereas for spolic it was less than or equal to 17%. So those are the current great groups. And then the subgroups, and this is just to give you a bit of an indication of the profile features. We've combined some of the original subgroups, we've moved some of the original subgroups, and we've ended up with 4 terms: albo, fusco, carbo, and aquo. So the profile features, you can read through that. Albo is mainly surface horizon, less than 2% organic carbon, or we've defined here, or a surface horizon with more than or equal to 2% organic carbon and less than 10 centimeters thick. There would be no evidence of prolonged wetness in the control section. And that applies to fusco as well. So what you see here is just a little bit of a difference in organic carbon content and thickness, but again, no evidence of prolonged wetness. And same with carbo. Again, here we're just increasing the amount of organic carbon. When we get down to aquo, then the surface horizon, less than 2% organic carbon, or greater than 2%, but less than 10 centimeters thick. But the important differentiation here is that we have evidence of prolonged wetness that you would see in the control section.
And sorry, I would interrupt there for a sec.
Please, yeah.
Aqua, I think that this is, so what you are describing here is albo aqua. Aqua is, in a general term, would apply to any organic carbon as long as there are evidences of prolonged wetness. So it could be a combination of albo aqua, fusco aqua, carbo aqua. So that multiplies number of individual subgroups.
Yeah, thank you, Constantine. Good addition. So then this is what we end up with. If you look at the 3 great groups, each of them have 6 subgroups. And I'll give you a moment to take a quick look at those based on the terms that were presented in the last slide. So here we're just incorporating albo, fusco, carbo, aquo, albo, aquo, fusco, aquo, carbo as differentiated, as Constantine mentioned a moment ago. So we can come back to those as needed. We have worked with 4 suffixes from the current CSSC and modified one of those, the P suffix, but we've introduced 4 new ones. So this is not too different from the paper. So we have suffix I, which indicates the presence of toxins or contaminants. We have suffix O, representing organic materials, greater than 17%. And you'll note the thickness that we've included for these suffixes as well. And then we have suffix Q, the occurrence of hydrocarbons, and suffix W, which is the presence of artifacts greater than 2 millimeters and occupy that greater than or equal to 20% volume of any of the horizons. We really struggled a little bit with how we would talk about these combined horizons. So hopefully that is clearer in the chapter that we have in draft right now. The materials and evolution. So there's a section in the chapter on anthropogenic materials. And then there's also a section on the evolution or the trajectories that these soils would evolve in. And so the anthropogenic materials, we've defined that quite clearly. I just have a few bullets here right now. Constructed or modified by humans. They could be mineral or organic, and they may include fragments of human-made materials. And we've also got a list of what those human-made materials might include that we're calling artifacts. And then the evolution, there were a lot of questions and a lot of comments regarding when is an anthroposol no longer an anthroposol? When does it become another soil order? And the foundation that we've worked on in our working group is when it can be distinguished by key features, diagnostic features, as being another order, that's when it becomes another order. And so we would expect that as anthroposols operate within the environment in which they were built, that classification will change for some of them. And at that point in time, they will be reclassified. So maybe some like Technic will be less likely to evolve to another order as spolic, for example. And then we've put the section, as has been traditional in the book, to differentiate from other soil orders. And right now we've got in there cryosols, chernozems, and rigosols. And we've got a little blank spot where we will include the leptosols once that chapter is a little more defined as well. It's really good we're following the family section discussion today, because we had a lot of discussion about families and how appropriate they might be and whether we needed to use them. So we've taken Ptero and Cryic, which we originally had as subgroups, and we've moved that into the family section. It certainly matches what we're currently doing with lithic, and very important to us, it reduced the cumbersomeness of the large number of subgroups. I can't remember the exact number, but we just had 96 or something like that, and it was just a huge number. So we started thinking about this when we're in the field. Are we really going to be able to differentiate those? And so by focusing on the family for Ptero and Cryic, we think we've made it a much more usable classification. Anthroposol position. This has been another long discussion, and it may not be over yet, but we are recommending at this point in time that anthroposols become first of the orders. And we didn't want this to be anything related to temporal factors or anything other than what makes sense in the key. And we thought by putting anthroposols first, that it actually makes sense in the key and it simplifies the key, because essentially, if we have anthropogenic material of minimum thickness, no diagnostic horizons for other orders, then it's automatically an anthroposol. Where if we have pedogenic horizons that define other orders, then we just move on in the key. So for those of you that were involved in developing the Anthroposolic order, and those of you that were at the meeting in January, that has always been a big question of where it fits. And it started out with, well, maybe it should be just at the end, because it's the only human developed soil rather than natural orders. But this is what we've ended up with. And of course, we're looking forward to what you have to say about that. So additions to other sections, I'm not going to go into a lot of detail here, but we've listed for you what we've actually worked on. So there would have to be changes to the control section from surface to 1 meter, or whichever is less. So it's a little bit different for the Anthroposols. We've added the disturbed D horizon, and that would occur in the sections just before mineral horizons and layers. I've talked about the suffixes and where those would be added. And then we would need to add tarot contact and artifacts to name diagnostic horizons and layers for disturbed soils. We would need to add the family criteria and guidelines for Anthroposols. There would be a need for depth classes, which we've listed here as an example. And then in the unconsolidated mineral component, we would need to add, of course, anthropogenic and including artifacts. And then finally, in horizon designations, we would need to indicate LFH horizons and how they would be used in Anthroposols, and the fact that they would be used only when leaf litter layer has developed naturally from vegetation on those Anthroposols. So that could be within a short or a long period of time, depending on the use of the Anthroposol and the type of vegetation that's growing on it. And then we were suggesting throughout the document that we change people to humans, seems to be the more appropriate term to be using. Now that takes me to the last slide in the presentation. And these are some of the topics that we're still discussing and certainly need to work towards a decision. And I've just listed them here. We can work through them in whatever order people want as we get into the discussion today. But the first one is criteria proposed for differentiation from rigosols, and is what we are using appropriate. The thought of using GJ for glide Anthroposols becoming glycols, subgroups of other orders, etc. And again, that's part of that transition of Anthroposols to other soil orders. In a lot of discussion, we've really talked about using the suffixes I and Q also for natural soils, because some of these soils, they need that description, but they really don't, they're really not Anthroposols. What just came up in one of our recent meetings is whether it would be useful for pedologists in the field to be having some color guidance for albo and fusco, in addition to an actual defined value for organic carbon. What about using WJ for 10 to 20% artifacts? Again, that was a lot of discussion. How many artifacts, how much, what volume, what percentage do you actually really need before it becomes an Anthroposol? And then the idea of using WJ or W in natural AP horizons where you have waste or garbage or human artifacts. And then the last one that we've put here for potential discussion is using DW. If you have this 50 centimeter horizon, but it might be above, it might be below. For example, we just keep saying, so, okay, if you have a DW below 50 centimeters, then is that a brunosol? Is it an Anthroposol? So everything else above that D horizon might look like another soil order, but is the fact that there is this presence below putting it into the Anthroposol group. So I would invite Constantine and Leonard to add anything that they would like to add. And they told me they were answering all the hard questions, so that works well.
Yeah, if you keep this slide on, that would help me with the
Sure. Which one would you like me to go
yeah,
to?
just the last one, back to what we
Okay.
were, yeah. So first is actually to the comment that I think the last Kevin had. Anthropogenic parent material have been with the Canadian system of soil classification for a while. Nobody used it much, but material is already listed. And that brings the topic of the very first discussion here. So I read, like, let's say right now, the only way to classify an anthroposol would be a regasol on anthropogenic material. There is no other really ways. It's freshly placed material on anthropogenic material. But we found that that's the whole beginning of this anthropogenic discussion and bringing it in, that it doesn't make sense for land management or soil management to call it regasols. It is different, and that's the first point. Anthropogenic material is already there, but is it regasol? We put criteria: any soil with no horizon development situ that is not on anthropogenic material would be regasol, and if soil with no in situ development would be on anthropogenic materials, that's what we call anthroposol. So that's the first point. That point of using W modifier suffix to natural horizons actually brings it to topic that Miles Dick was bringing about Lewis soils being significantly altered by humans. So many cultivated soils would have some garbage in their surface horizon, and would that qualify them as anthroposols or material as anthropogenic? So that's where we would think APWJ would be appropriate, let's say, but it is to discussion. And also we don't discuss, we discussed, but we refuse to put any numbers to the concentration of hydrocarbons or toxins in anthroposols, because jurisdictions have different parameters, different values for that concentration. So natural soils may have some invisible contaminants. That's relatively common, and that would not change trajectory of soil development, yet it is to be recognized. So should we use I and Q in natural soils when they are contaminated, or they have metals, let's say, above guidelines layer levels, but the concentration of metals is natural from bedrock development? Okay, that's all I had. Thanks.
Okay, Leonard, did you want to add anything?
Well, the only one that is quite tricky is this G and GJ. It's like we have aqua for the wet ones, and if it's not wet, it's the other orders or subgroups. We call them modal, but modal becomes redundant, so we eliminated that this round. And so the issue is really, you can have some models in there, and at what point do the models send you into a natural order away from the anthroposols? And we think we've got a system now, but is everyone in agreement with that? That's a tricky one. you know, we went through a system where we introduced glide Anthroposols to be really the imperfectly drained soil in the cross section. And, you know, we considered changing aqua to glycolic. But initially there are no models to work with. So how do you define a glycol versus glide versus modal or orthic? And, you know, you get to things like occasional wetness or prolonged wetness, and that's all subjective. Guaranteed everybody out there, depending on time of year and so on, would come back with different groupings. So we kind of stuck with the models being the determining factor to take out or to identify a glide or what would be an imperfectly drained soils. And initially, we're not able to do that. The models aren't there. After maybe 10 or 20 years, they either meet requirements of a glycol or a glide profile. So do you need a B horizon or an AH or some other soil order to put you into a natural order? Or once the glide is there, can you go to a glide Rigasol? Or do you stay with a glide Anthroposol? So we've had countless debates on this, and here's where we are today. That's it.
All right, thank you. First question from Graham Spires. Graham, you're muted if you're talking.
Sorry, thank you, Dan. Anne, could you please put up that last slide again if you're done lecture?
Yep, I can. I think I can. Hang on a sec.
While Anne's out hunting for the slide, I'd like to pass a comment here. Having worked on what I call Technosols, and now I do somewhat happily refer to as Anthroposols in this region, I'd like to kind of congratulate the team on all the effort that went into the background of putting this together. And I'd like you to look now closely at the head-on, which is displayed in this slide, and give you a little bit of history. When we were working on this site years ago, about 8 or 10 years ago now, I was amazed. This is a 50-year-old mine tailings. And I would think all the pedologists in the group here would happily describe a series of horizons in that right now and say we were looking at some sort of Brunasol maybe, but it ain't, or is it? When we're looking at the change from Anthroposol to other orders, do we have a time cutoff or anything like that? The evolution in some of these materials, which are dumped by humans, pretty rapid. This one, I was moving it to the Brunasols back in the few years ago because morphologically or just from an image, that's what I thought we had to do. Am I right or wrong?
I would comment that I have seen brunisolic BM horizons developed in placed tailing sands after 17 years. and they were borderline. So, but I was ready to move them, and I saw prominent mottling developed in a research plots that were monitored every single year after placement. So in 5 years, prominent mottling became visible in upper 50 centimeters when drainage was really poor. So
this one is in an upper slope position, and if we actually get inside it and pull it apart with a knife, there are fine to medium models. They are, some of them faint, but some of them are quite distinct when we pull this particular one apart. So, and it's a bit older than the Western ones that you're talking about, Constantine. But evolution can be fast in these things. Or petagenesis, should I say, not evolution.
All right, thanks, Graham. Richard.
Thanks, Anne and Constantine, and who's the third person? Mine is slipping my mind. I congratulate you on the effort that you've been putting into this. One Leonard. One question I have is, how, on one hand, how is this aligning with some of the other efforts that are going on internationally to try to develop systems to classify what we would consider anthroposolic soils and the transitions to natural soils? That's one thing I'm asking. Another point I'd like to raise is I'm very impressed with the fact that you sort of pulled out this Fusco elbow and carbo in trying to create some kind of framework to differentiate the different types of horizons based on amount of carbon. I've got quite a long and bit of experience with the system in Brazil, and they've actually got 6 types of A horizons. One of them being Chernozemic, one of them being anthropic, but the others are really along that gradient as well, where we've got they call it weak, moderate, prominent, and humic. So there is a framework that they're using to distinguish all of their soils, the A horizon on all of their soils, potential on all of their soils, according to this coloration and organic matter content. And what you've raised here perhaps might be worth reflecting on more broadly across the board, especially when one is considering the realities that we often don't have natural soils anymore. And we've got mixtures of in agricultural landscapes, that is, we got mixtures of varying amounts of what used to be remnant organic A horizon with some subsurface horizons and recent additions and so forth. So along that whole line of reflecting on being able to distinguish according to coloration or organic matter content. You've introduced some new suffixes. And I know so there's some of these letters that seem, when we're working with the organic soils, they take on a certain importance, and when we're in the mineral side, they take on certain importance. I'm wondering if we're comfortable with that, or whether that needs a little bit more reflection. And the thing that I'd like to throw out in this whole issue of suffixes, yeah, we're quickly exhausting our normal Latin alphabet. Has there been any thought at all amongst the group? Why aren't we taking advantage of the Greek letters in some way to provide us with a little bit more flexibility in being able to express features with a limited number of letters? That's my third point. And my fourth point that I left for the last is because I'm sort of trying to come to grips on my own, but also with the group, that looking at these redoxymorphic features is the how you're handling the presence of modeling, and you've come up with this aqual term, and yeah, and then how does that integrate in, because it can be very quick if it's in a depressional area and you've got some ferruginous material mixed in with with this spoil or whatever has been thrown in there, goes anaerobic, and suddenly you can have all kinds of rusty spots forming all over, which is not necessarily depositional anymore. That's actual landscape processes that are taking over and starting to transform that. And along that same line is, I think it forms part of the continuum that we've got soils that were naturally poorly drained, and so you saw these concentrations of iron, this modeling and so forth. But when you install some kind of subsurface drainage, it sort of locks in the situation. And how do you distinguish then those soils whose redoxymorphic features are actually reflecting current conditions versus those that are remnant? A lot to unpack there.
A lot of good points there, Richard. I'll answer the first one from the perspective of other jurisdictions, other countries. Canada is behind. Other countries are much more advanced. And you can read that in our 2022 paper. We've updated the status for anthroposols or anthrosols or technosols in other countries, other taxonomic systems. So if you want to take a look at that, and if you have any questions, let me know. It's been an interesting search that we've been doing to see where other people are at. As for the suffixes, we were talking about that in our working group as well. We're starting to run out of an alphabet. And so certainly looking at perhaps grouping some of them in the system itself is something that I would certainly support. I won't speak for Constantine and Leonard, but there might be value in looking at that. So Leonard, Constantine, do you want to respond to either of those 4 points?
From practicality, yeah, please, thank you. So from practicality of suffixes using other alphabets, Russian, Greek, Mandarin, would be difficult with computers. So using symbols like that would limit technology. We have precedents of using double letter suffixes. Let's say C stays for cemented, but Ca stays for enrichment with carbonates, right? So we have double letter suffixes. So I think that's the direction we may move toward, rather than using other alphabets. That's my opinion. As for first point with other classifications across the world, we are behind in incorporating anthroposols or technosols, but we are some sort of ahead of the game in digitalizing reclaimed soils. Many soils across the world, when they are recognized as technosols or so, they mean artifacts or man-made materials in general, like rock or so. Reclaimed soils usually are not addressed very well, and that's why we not just simply copy-pasted a system from, let's say, world reference base for soil resources, because we want to address our Canadian issue. We are kind of ahead of game with land reclamation, and we want that topic being addressed in the classification so we can speak the language of land reclamation. So that, and
that's a really important point, Constantine, that we are ahead in the depth of the work that's being done in the anthroposols. But maybe just to clarify what I meant by behind, it was more the formalization of the order.
Yeah. And what was the third point? My memory is short.
Was the
Richard,
glade?
you got 2 middle ones.
Yeah,
it was the gradient in carbon content to distinguish different types of horizons. I think that's quite interesting.
Yeah, we basically, like nothing particular new we introduced. We followed the 17% organic carbon content. So that was straightforward between mineral and organic soils already. and we followed difference between well, there is already like difference introduced in, let's say, Chernozymic order definitions with less than 1% organic carbon. It's not a Chernozem. So we introduced 2% organic carbon instead of 1. We may move, but that's the idea. So we followed the concept that is already in Canadian system. So percentage of organic carbon. We started with colors, but we avoided using colors because even organic materials in Anthroposols could be white colored. Let's say sawdust could not meet criteria of dark color, but yet it is organic material 100%. Same with some topsoil horizons could be made of B horizons, so they would be not black, but rather brown. And it's just so much variety within Anthroposols that color is not relevant. We avoided it on purpose, but we're now bringing it back to discussion to confirm our consensus. And the fourth one was, oh no, mottling. So the mottling, there is a way to, it was discussion of our group from the very beginning, how to distinguish between relic mottling and in situ mottling. It is a constraint, let's put it that way, but there is a way to distinguish. So broken edges, random orientation of models, that would be all criteria for relic features. And if model is oriented along pores and it has gradual outer limits, outer boundary, a pedologist, qualified pedologist, should be able to recognize. If people can't recognize that type of modeling, that probably is a problem of qualification rather than absence of features. That's our approach anyhow. And yeah, that's all I say.
All right, thank you. Let's move on to Dan Pennick, please.
Thank you, Dan. And again, like the others, I think you've done a great job, folks, on this Anthroposol order. It's wonderful to see it firming up and so on. I just had a question, and it's more of a clarification. I mean, ideally, we dig a soil pit, we describe the profile, and then we use that to assign master horizon suffixes, and then we classify the soil based on that. I guess I'm not clear what the ACWO, what is it we're describing? Like what would the criteria be for, is it ACWO or non-ACWO? I don't have a sense of that from it, from the presentation, and I'm sure for time reasons, but if you could just clarify that a bit on what makes something ACWO.
I can do it. Yeah, we put 3 criteria there. One is presence of water table, simple. So water saturation, water table. Second criteria is presence of aquatic vegetation on surface or in nearby landscape. Let's say we have a disturbed well pad and we have aquatic vegetation or wetland vegetation surrounding it. That would be criteria for that as well. So water table, saturation. What was the third? What was another one? Aquatic vegetation, and I'm missing a parameter. So I put water table. So saturation.
It was the presence of wetness, which would if you could visually see that.
Yeah. So that's pretty much it. Ponding of water and at surface. That was another one. So visual evidences of water, like wetness, and aquatic vegetation would help, but mottling would not, because it is a short time since material placed. So we don't expect mottling or gley colors being diagnostic.
Yeah, I guess my concern about a little bit, it's maybe not the credit vegetation, but the other things are quite ephemeral, right? I mean, if we go out in spring, it could be an aqua, and if we go back in fall, it would not be. And that's it's a little bit of a worry, and it gets, you know, it's almost like what we were talking about with the modifiers. Was that, I'm trying to remember that Jim had talked about, where so salinity has been perennially difficult to map because, you know, here today, gone tomorrow sort of thing, right? And so the classification chose not to deal with salinity very well, certainly not at the subgroup level, because it was viewed as ephemeral. But the aqua would certainly be ephemeral as well. And I can see it being, the things that are that ephemeral are difficult to incorporate in to the subgroup and other levels because it will very much depend on time of year in some cases. So anyways, it's just a comment I have that I do find the aqua a bit inconsistent, I guess, with many of our other subgroup level criteria. And it may be better placed as a phase or as a modifying factor because it may not be there if you go back in 6 months.
And we would totally agree, it is ephemeral and it is inconsistent, and that's particularly reason why we didn't separate glade and glycolic or slightly aqua and fully aqua yet, because even separating aqua by itself is already a challenge, and we assume poor and very poor drainage as much as landscape position, vegetation, presence of water table would tell a field pedologist, but there is a limited number of tools we can use, and models is not one of them. But we want to separate it because it is different land management, this different soil management, and it indicates where potentially soil may evolve into. So that's why we want some sort of it in classification, but maybe not necessarily aqua term or aqua subgroup. We are flexible, but that's where we are at now.
And the, you know, the ephemerality, I don't even know if that's a word, but you know, certainly when you have vegetation and that's longer term vegetation, you know, a few years or whatever, would indicate that it's not just a springtime thing, but it's a longer term. So, but of course, you don't see that in all of the anthroposols where we would apply that aqua to it. Points to ponder, Dan.
No, it's a very interesting one. It's because I think salinity has the same problem, the same issues, right? But I do think I see that Kevin made a comment about site clues, and I think often a site clue is landscape position. I mean, that it's likely to be, and I think we also, in terms of drainage, we don't take into enough account of discharge positions as well. They're also going to be lower slope positions. So I think as well, including a landform or a landscape position, which makes it likely that it will be experiencing wet conditions, would be a good idea.
I agree, that would be a good one. Depressional positions could be added to the list of potential prolonged wetness indicators.
Yes.
Yeah.
Yep.
Thank you.
Thanks, Dan. Jim.
Okay, thanks. Okay, I'm gonna sort of go through this and sort of summarize what I think I'm seeing, and with a couple of points, and then just so I understand, and maybe so that the whole group understands here what we're doing. So first of all, one of my major concerns with including the anthroposols right from the get-go was where it's going to fit in the key. And I'm glad to see that you've decided you think it goes at the front. I think I have to agree with that. So I think that's a good thing. The reduction of the number of subgroups, I think you've done very well. So in terms of how it's evolved, I guess is looking very good. So I commend you on that. One of the things though, right now, the way I look at it is, okay, so you're going to the field and you're looking at the key and you say, okay, this has got a D horizon, it's an anthroposol. So the way it appears that you've developed your anthroposolic terms they're kind of unique to the anthroposolic order. So you're not, and correct me if I'm wrong, but you're not going to use any of those terms on any of the other natural soils. So it's sort of a unique order in that respect. So am I correct on that?
I think you got a
You're
good.
correct in the sense that we develop them and we develop them based on root words as to they would be definitive for the property we're trying to define. Whether they would be applied to others or we would change them, and that's always open, yes.
Okay.
We may, instead of using term presence of D horizon more than 30 centimeters thick, we may say presence of visual evidences of disturbance in a horizon thicker than 30 centimeters. That would make properties in the key, not rather than a definition. So we have to look into the definition first, but maybe that would be more practical.
Okay. And so, no, as long as, okay, I think I'm clear on that, in that, okay, you defined it, okay, however you define it, this is an anthroposol. Okay, so you go down through the key, through the key. And the next thing I wanted to, was sort of curious about, is once you get to the family level, is it, you defined a couple of terms there for cryic, I think it was cryic and enteric, if I'm not mistaken, going back. I don't want you to go back to the slide, it's okay. But are you going to apply the current or modified family criteria to the anthroposols, or have you got your own ideas as to what you're going to do at the family level? And I guess from that, are you going to classify series or map series within the anthroposolic order or something else?
Well, the rationale why we move Terra and cryic into the families is because they affect soil management in lesser degree than quality of topsoil or presence of artifacts. So if someone wants to go in details of land management or soil management, there is a place called family level. So go there and apply Terra and cryic and lithic. But in subgroup level, it's not necessary. We can go, and we should at one point, go to series level, and that would definitely include family in it necessary. That's the hierarchical level. Yet, correct me if I'm wrong, but there is a particular minimum for area that were to qualify for soil series. It should occur at a minimum of particular area. Otherwise, it's not a series. So
Yeah, well,
we are not.
Yeah, there's arguments there as to what that minimum area should be. We in Ontario, for example, the minimum area based on can't remember what the name of
Soil Survey Handbook.
publication was. It's Jerry Cohen, who was the author, or one of the authors at least. Anyway, and it's 800 hectares is the minimum number based on that publication. We in Ontario, we've run across a lot of our soil series. The actual area that's been mapped is way below that. So it's not, it's obviously out there, but it's not really a hard and fast number.
Yeah.
Okay. So.
We are preparing Orange Book. We are not making soil name file yet. So series is outside the scope we're working now. But we
Fair.
assume at
Wonder what
one
your
point, someone will classify series apply to Kansas and eventually get the name in. So far, we're using, like, practically myself, I'm using ZPR as a soil series code, miscellaneous permanently reclaimed soils, or ZDL as for miscellaneous disturbed land. Those are the two categories we practically use. They're not so series, they are composite units or
Yeah,
something
fair
like that.
Okay. Yeah, for now, that's fine. I just, again, I was just wondering what your thoughts were on where you're going with that. I was gonna wade in on the aquas term, but I'll leave that for another day. All right.
Just one thing I'd like to add here is I hope we get to series, because not all Fuscos will be the same, just as not all black Chernozems are in the same series. And it's a way of capturing some of the subtle differences, but important for management or land use, whatever. And so I really think we do have to get to series. Also, going back to suffixes, we could use the alphabet following W for the different kinds of artifacts we might encounter. So rather than trying to distinguish them in the classification system, we group them, and then at the series level, you could get into the details. And some of the wastes are very different than others, like wood products eventually will decompose, they'll be gone, metals won't, concrete, somewhere in between. That's my bit.
Thanks, Leonard. And we've got a couple of minutes left on the agenda today, and so we'll try and wrap up. I'm not sure, Anne and team, what your thoughts are on next steps for the Anthroposols. I will throw one more idea your way, and I'm wondering, right now in the parent materials we have anthroposolic parent materials. Is there a need to, if we're going to start looking at family descriptors for anthropogenic soils eventually, or anthroposols, and then series, is there a need to consider maybe refinements to the types of anthropogenic parent materials that are in the system that we use? So, right now, for example, under mode of deposition or parent materials, we've got till, and we've got glacial lacustrine materials, glacial fluvial materials, and those, as you go through the sequence of the hierarchy of the system, when you go through family down to series, those become important for differentiating. And so might it be a step in the future, not right now, but a step down the road once we got the basic framework down, to start looking at potentially, describing some of the more common anthropogenic materials that we would encounter on the landscape. They're obviously going to be associated with the types of development projects that are ongoing, but just something to throw out there.
Yeah, thank you for that comment, Dan. Certainly that's something that that would make sense, and we would look at down the road as well. As far as next steps go, we're probably going to be sending our chapter and our key out to our larger working group again shortly. And then at some point, I don't know, do you want us to submit that to you and the larger working group? That would be your call as to when you want to be having us send that out, or you send it out.
We also want to work with you, Dan, and like your group on including the leptosols. So maybe having maybe we can send you a draft of that section of the chapter, and you can just write down that particular paragraph the way you see it, and we will see if your version is acceptable to us, and then we'll go back and forth a few times. And the same maybe with only leptosols at this point. I think missing it's a gap that we left
that's our big gap
purposely. Yeah, we need to submit this draft to approval, to review approval. That's the
Yeah, so I think
that's what we do. That's
Yeah, I think, Dan, I think that your suggestion was good. I think you have a larger group that had worked on the Anthroposols, so I think it makes sense to maybe finalize kind of what the smaller group has been working on and maybe send that out for review to your larger team of people working on the Anthroposols. And then once you've come away with comments and kind of sorted those out, maybe then we can discuss how we would approach the larger group again like this. It might just be, maybe we'll do another presentation where we'll spend, the whole 2 hours maybe just going through the chapter itself and the content and try to get some agreement on it. And that'll have to happen for the leptosols as well. And so actually the leptosols is probably something that, the four of us that put that one together, we'll have to take some of the comments from the last meeting. We haven't met yet to start that, but we're going to have to start looking at some of those modifications as well. And so we could have back and forth with the anthroposolic group as well for the aspects that kind of interact between the two.
And that sounds good. We have had the smaller working group look at the draft already. So we received comments from them, we modified it, but now we would send it back for another look with the modifications.
And maybe before we do that, we should receive a response from the leptosol group and a response from the family group. I'm looking at you, Jim. So because we introduced 2 new families, so that's the second gap we have. Well, not gap, but like, do you accept it as a working group on families, and we can keep it that way, or there is a contradiction somewhere we may be missing, and then we can give it to our larger group again for review. And what do you think?
Yeah, no, I agree. As Jim was presenting on the family, I was thinking it would be really worthwhile for you to look at what we put together and then make sure that it's jiving with the direction that you're moving in. And certainly the leptosols, that's the one blank paragraph that we have in our draft that we need input on. So I think that would be good. Get some, get some feedback on those 2 items, then send it to our smaller working group and get it to the point that we're all comfortable with it. And then back to you, Dan, then you and I can decide, do we send it out or how do you want to deal with it?
Okay, that sounds good. So we're over by a few minutes, but that's okay. So a reminder that we will meet again in a month's time. The next meeting, we are going to cover, we're going to get an update from Richard Heck's group on redoxamorphic features. And then we're also I'm going to collate together. I'm going to try to get this out to everybody in the next week or so, but a list of the items that were submitted on our online form. So these would be kind of small to moderate changes that are being proposed to the system and to the structure of the book itself. And so I'll try to compile all of those and get those out so everyone has a chance to get eyes on it before the meeting. There are quite a few comments, and so I will try to get that done. And then, of course, the week after our next meeting, we have the CSSS, which is going to be it's hosted by Brandon and team at DAL in Truro. So other than that, I don't have anything else. Brandon, do you have anything?
Dan, do you want to update them on the CSP stuff?
No.
Yeah.
So we can, so we have good news over the last month. Since the last meeting, we can give you an update that we have signed an agreement to acquire the copyright of the Canadian System of Soil Classification. So pending payment of our invoice to CSP, that the 3rd edition and any future editions of the Canadian System of Soil Classification are now copyright to the Canadian Society of Soil Science. And so, hooray, we can do what we want with it now. Without fear of being sued, I guess. I don't know. They never went after AAFC, and AAFC was vending it for free on their website. And so I don't think they were ever too concerned about, people giving a free a copy of the system out online, but. So there we go. So that was good news. And so we were hoping to get it done before the AGM, and well, we did about a month before. So that's good. All right. So we will see you all. Again, the video will be posted. I'll send out a link. I will also send out those collated notes for the smaller changes, and looking forward to seeing you all in 1 month's time. Yes. And then Brandon, are we having a pedology committee meeting at the CSSC?
Yep, there's one set up. There's also a special session hosted by Richard on the future of pedology education, which will be made online for those of you who can't attend it. I'll send out some details about that at a later date.
Perfect. So there'll be no shortage of pedology talk at the CSSC this year, which is great.
Yeah.
Brandon,
Yeah.
I would have a question after the meeting, maybe related to that session Richard is holding. So maybe you can stay.
Yep. Okay. Sounds good.
Just 1 minute, short question.
Thanks, everyone.
Yep.
Okay, thank you.